Hello, good folks, and welcome to BWT's series of multimeters. Today is number 6 of 6, and we're going to be covering the extra functions that's available on some of the multimeters. That being said, we're going to cover today the hertz, and some of the meters, you know, they'll have this, and then what that's doing is it's sitting there measuring how many cycles per second that a circuit has. And sometimes you can measure the AC, DC, and also in volts or the current, all depends on the meter. And so anyway, what we're measuring is one complete cycle per second, and the units are hertz, as I said. And here is something that I want to talk about, and then I will show you what's going on with a low pass filter. You'll want to make for sure, you know, that depending if you're going to do a lot of electronic measurements and stuff, that you'll want to get a meter that has a low pass filter, or I'll show you what you'll end up getting with the interference. And next we'll be covering capacitance, which is the ability to store a charge. The units that we measure that in are farads, and then it's got like picofarads, that's 10 to the 12th, so it's got 12 zeros behind it. We're going to cover diodes, which is basically like a check valve. It's a one-way switch, and also known as a rectifier. You can take AC current, and since it won't go but one way, you're going from positive to negative, you're going to cut off half of it, and then it'll make a pulsating DC current. And then hold, that's actually just so that you can go ahead and then hold whatever the value is, so that you can see what the display is. But I want to address safety on that, because if you don't take it off a hold and you go ahead and you check another circuit or check something else and it changes, you're not going to see that change. Now, you do have some of them that have an auto hold. If you go ahead and put it on that, it will go ahead and change, but it takes a certain amount of time when it detects the next stable change of voltage or whatever it is that you're measuring. But it's still, you want to be careful when you're using a hold, because you know you can't always trust the changing variables of a circuit while you're testing. The min-max, we're going to cover how to do that and what that is, and it'll tell you also that some of them have the average, but you got to set them to manual, and you got to select your range before you go ahead and then do the min-max. And then some of them have a bar code down there at the bottom, or it's a bar. And actually that is really good for troubleshooting, you know, on things that you don't, the display only shows changes 4 times a second. And then right here, the bar changes 40 times a second. So if you've got a circuit that's dropping out just real quick, your display is not going to pick it up where you can actually watch the bars, and then they're going to go ahead and display the relative to the full scale value. You can watch that thing going up. It's similar to like a old analog type meter where the needle, you know, you could sit there and watch it fluctuate. And then we're also going to go ahead and take care and show and demonstrate the temperature in Fahrenheit and Celsius. So bear with me. I'm going to go ahead and get this all set up so that we can view over here on this board, and we're going to go through some tests and let you actually see it. But before we do that, I'd like to go ahead and then offer this to anybody that's interested in getting into the maintenance field, troubleshooting, or anything that's involved with industrial maintenance. This is a checklist for launching a career as a multi-skilled maintenance technician. It's free. It just goes through steps that you need to do and take to prepare yourself and know what you're doing and what area that's best suits you. And like I said, it's free. You can find it in the description, and then it'll give you a link to a PDF file so that you can print this document off right here. And it'll help streamline you and help fast track you to a successful career. So give me a minute. I'm going to go ahead and reset up over here, and we'll do some testing. Okay, folks, I'm back. And as you can see right here, we got voltage, and the first thing we're going to test is hertz. And to do that, you're going to be on a live circuit. So I'm going to go ahead and put on my proper PPE. And you should do also anytime that you're testing live circuitry, just to be safe. And as soon as I get these gloves on, as you can see on this meter right here, this one allows us we've got the hertz on AC, DC, volts, and we got hertz on DC for milliamps and for just regular amps up to the 10 amp max. And then that's for current. And the test we're going to do today is we're going to go ahead and we're going to do it on voltage. So we set it to volts. Then the next thing that we do, I'm going to turn that light on right there for you, so that maybe you can read that display a little better. And we want to go ahead and we're going to select our range, put it in manual. And then we're going to set it to hertz by pushing the yellow button. And right here, this is a 110 feeding into a little power supply. And since we're here in the United States, it should be around 60 hertz. So I'm going to turn that on. And we put the red lead to the hot, the black lead to the neutral. And as you can see, we're right at 60 hertz. It's 59.99. So that's good. Now I want to show you what happens when we actually turn on a frequency drive. Remember I talked about the low pass filter? Low pass filter does just exactly that. It goes ahead and it filters out interference. Now watch what happens as soon as I go ahead. We still got it set to hertz when I turn on the freq drive. Now when I come over here, see how it's all over the place? It's not reading our 60 hertz or anything. It's giving us a false reading. So you need, if you're going to do anything around a freq drive, you need to be able to measure, things, or otherwise it'll also mess with your voltages and stuff. A low pass filter will help you go ahead and isolate stray voltages and stuff that you'll be reading. And we'll shut this off now. But see, should have been reading 60. And it doesn't make a difference whether we go ahead changing the hertz. It just can't read it through all the interference without having that filter. So we'll shut that down. Turn it off of hertz. Get it back to auto range right there. And as you can see, we're going to go ahead and let that zero out a little bit. But with this freq drive, we get over here close. See, even in volts, we're picking up all that stray, or called the ghost voltage. I'm going to go ahead and shut my power off right now so that I can take these gloves off, and we're going to do a capacitance test. Okay, for capacitance, we're going to set it to capacitance. You can see right there, it's yellow. So we're going to go ahead and push that. And as you can see, it's showing that it's in nanofarads, but it's auto ranging right now. And I've got a couple little capacitors down here for us to test out. This one is a 10 microfarad. So we're going to go ahead and put it on the leads. And as you can see, is 9.95, so it's within its range of what it says that it's supposed to be. Now I'm just going to show you this. If you reverse the leads, you still get the same thing. Okay, let's test one more right here. This one is 100. So let's see what we get on that. And we get 100 microfarads. That's dead on the money. So that's all there is to, capacitance test, is we just got to make sure we got it set to capacitance. So I'm going to get that back off of there. Our next deal is going to be checking a diode. And as you can see, the symbol for a diode is on our beeper. So we're going to set that to the diode setting. Push that. And it gives us a little diode symbol right here. And a diode, how to check it is you're going to measure it both ways. You'll get a reading one way. You get an OL the other way if it's good. So there's our OL. We're going to reverse the leads. Oop. There you go. So see, when we reverse it, we got 0.579. We go this way. We got OL. So that diode right there is only allowing current to pass one direction, so it's good. So we'll get it off of diode. And our next test is going to be the hold function. So the hold function, you can actually hold on anything. I'm going to change out my leads right here. And then I'm going to get a pot or a potentiometer. And then I'm going to show you, it's a variable resistor. So we're going to go ahead and set it to resistance, because that's what we're going to be checking. So you can use this hold for whatever value. So if we take this, okay, so right there we got 3.64, and see it'll vary as we're turning it. But now I'm going to go ahead and I'm going to hit hold, and it's showing that we got hold right here. And see, I'm turning it, nothing happened. We didn't see any change. So that that's telling us that we've got to be safe with it. So if I go ahead and hit the hold again, that shows the change. So, anytime you use a hold, that's really just so if you can't really read your display or something, you can push that hold button so that you can pull it out to see what value it is. Okay. The next deal that we're going to go with is the min-max. So you can do the min-max with resistance. You can do it with voltage. So since I've got this already set up in my hand, we're going to go ahead and we're going to do the resistance right now. And just show you that. If I can keep these little ends on here. All righty. Let's go ahead and let's get it to the right range. We want to get it off of, and this is a 10K ohm resistor. So that should be a good range right there. Now we're going to go ahead and hit our min-max. And as we do this, you can hear it beeping. So it's calculating out what the changes are. Okay, and now we're just going to click that. So we're going to click it once. That shows our low. That shows our average. And that was our high for that point of time while we were doing the testing. Okay, we're going to take it off of that. Just hold it for a second or two. And then I'm going to change the leads again, and then we're going to go back, and then I'm going to do it on voltage for you. we'll set it to, we're actually going to set it to DC volts, because we're going to check this out right here. Power supply. Okay. And since we're going to be just on the DC side, I'm not going to go ahead and put my gloves back on. But we're going to turn our DC voltage back on. We put our negative to our negative and our positive to our positive. We got 24 volts right there. We just did our min max. And we're going to adjust it. We're going to turn it back down. All right, let's see what we ended up getting. We went down to 18. Our average was 22. And we went up to 29. So just by clicking through, you know, you're going to jump from one to the next and see what your min-max is. And to get out of it, you just hold your min-max for a second or two, and then it'll put you back to the one that's not, you know, highlighted in the yellow or by your function keys. Now, let's go ahead and then we'll do the bar. As you see right here, there's a little bar. If I go ahead and we're on DC, see, that's showing you your bar right here. And if I sit there and then vary that, you're going to watch that bar go up and down. See how that bar is moving back and forth? If you watch that, when you're actually watching a switch, you can see what the voltage is doing, whether it's going up or down, but quicker than what it's going to show up on the display. So let's just say you got like this contactor right here, and the contactor is dropping out. You know, you've got a weak set of contacts, and it drops out and makes maybe, you know, a relay or maybe some other component, you know, drop out and not function. And then all of a sudden it comes back on, so you got an intermittent problem. You might be able to go ahead and detect it with your bar, whereas you won't be able to see it with the display. All righty. And then the final thing that we're going to go ahead and cover today is we'll have to use a different accessory, and it's temperature. So this meter is set up, and it's got its own little thermocouple right here. You plug it in, and as you can see right here, there's a little thermometer. We're going to turn it to the thermometer, and then we have to, since it's yellow, we got to put it to that. And as you can see right here, that's in Fahrenheit. It's 90 degrees in here, rather warm. And you can go ahead and click your range, and it'll put you to Celsius. We'll go back to Fahrenheit. Now, just to show you that it does work, I've got a heater gun right here. And it responds pretty quickly. And that's it for the meter series, folks. So if you like this series and everything, and you got any other things that you would like for me to cover, you know, to create a series of lessons and stuff, just let me know. And then we'll go ahead and we'll try to make some videos for you and give you all the tools and everything that you need for success. Have a good day. Thank you.